Good afternoon, good morning. This is Delvin from Javelin Technologies, and we're here to talk about how you can add electronics to your product design workflow. So I'll kick off simply by talking a little bit about Javelin Technologies. So Javelin's been around in the business for 20 years, and we're a Canadian-owned company which works with SolidWorks and helping our customers get more productive using design tools. We're based in Oakville and we have 6 offices across the country. What that means is everyone is certified in all the products as they support you and help you transition through special design situations, and we've got over 100 employees and we've been in the business for 20 years. The one key thing about being spread across the country is we have 13 hours of support to kind of help you with your design processes. So what we do as a whole is we ensure that our customers are able to help their people or focus on their people, build them up through ideas and concepts, put the technology in front of them, help them with testing, documenting, eventually collaborating and redefining the process such that it's optimized enough to push it through manufacturing. So all in all, it's an entire life cycle, and we tend to make sure that we support every stage of this. A quick introduction to SolidWorks technology. So for those of you who have never had a chance or the opportunity to work with some of these, SolidWorks is simply designed to work in the 3D environment, and it later on built on different platforms, so you can take those 3D concepts and you can test out simulation to make sure your designs they go through the right testing structures or studies such that they can be actually pushed into the market. Electrical is there to ensure that you have that seamless collaboration both between mechanical and electrical design, and just overall a faster solution to make sure you can get those schematics out the door. There are some other technologies too, plastics. We've got SolidWorks Motion, but today we're here to talk about SolidWorks PCB. So for those of you who have not had any exposure to SolidWorks PCB, it's powered by Altium. So what that really means is SolidWorks partnered up with Altium over the course of a couple of years, and they've ensured that they can bring in seamlessness between the PCB design world, both from a schematic layout level to the 3D world, where you can plan for how casing and housings and such can be incorporated within that product design. So I have two images on my screen right now. So the left hand is SolidWorks PCB, which happens to be an entire solution which works coexistent with SolidWorks. And on the right hand, we have a PCB connector. Now this ties in any of Altium's tools for working with SolidWorks. So if you have Altium Designer and you want to interface in with SolidWorks, you have that ability to do so. Bring those 2D layouts into SolidWorks and you can then plan for fit and form. Now, a traditional PCB design landscape usually revolves around a lot of file exchanges, mostly DXF. So, there's a mechanical side of things where you do have case design, board outline constraints, then the interference checking, final assembly, and on the PCB side of things, there's board outline, placement, revised placement, and routing. So all this information has to go back and forth a couple of times before a prototype is actually ready. So as this case built on, we realized that there's a disconnect between the design tools. 50% of engineering time is spent in component research, library management. There was still more work to be done in electrical and mechanical integration. And a cost of a prototype is moderately prototype is about 8,000 or so. So overall, every time you made a mistake or you wanted to go back to the drawing board, we noticed that our customers were spending quite a lot of money. With that, let's start talking about how this product can collaborate. So this is a standalone interface for SOLIDWORKS PCB, and the product typically revolves around a schematic package, and you also have access to a layout package. So in here you can do your 2D layouts, and you can sort of map out and figure out how things are going to work. So I've already placed a couple of components out over here. This is the board layout, and on my right hand side I have something called as the PCB connector. I'm going to push this layout information over to SOLIDWORKS. So I put some notes in there so that the other end of the design process, you're able to kind of map out what's going on. So once we pull this out, we now have access to the information that's coming in from our particular push and pull process. I'm about to create a new assembly, and this assembly will bring in all the features that were sent out from SOLIDWORKS PCB. So now I have myself a new board. I'm going to, excuse me, I'm going to now place that board within this particular case. So this is a case which I've already, a plastic case, which I want to make sure the board fits within this case. To ensure that, I can simply insert that board as I would insert any other part in SOLIDWORKS, place it. You can also go ahead and mate it. So I'm going to go ahead and simply begin the mating process by selecting regions that I'd like to mate. So in this case, we've got that, and can turn that on and let the coincident mate kick in. So as soon as that mate process is complete, I'm going to go ahead and change the outline of this particular board. So to change the outline of this board, I can simply edit the sketch, and we can go ahead and delete some of these sketch lines. And I do have a profile line that I've sort of created within my case. I'm going to convert those entities. As soon as I convert the entity, I now have a new reshaped board that fits my casing. I can take this information and go back to SOLIDWORKS. I can go back to SOLIDWORKS PCB and ensure that this information is transitioned over. So in here I can push this and I can say board reshaped to case. Push that information over, and in PCB I now have a new message that comes in. Now I, as a designer, can decide if I want to view the changes or discard the changes. So I'm going to view the changes to see what exactly happened. And there you have it. You can actually see that the outline of the board has now taken into effect. So let's accept these conditions. So I do have my board outline. It's brought it back into SOLIDWORKS PCB. But go ahead and get the shape of the board from SOLIDWORKS. It's really good because now I have more of an idea of how I'm going to place my components around the plastic casing. So I can then simply import the changes from the project, and as I do that, it's going to go ahead and give me those options, and I can place these components on the board. So the first thing I'm going to place is over here, and as I place these components, I can obviously rotate them simply using simple shortcuts like spacebar. If I do overlap any component, you can see you get graphical warnings. In this case, it turns red in color. So I do know that something's wrong. I'm going to put this last component over here and place it as required. I am going to place this component just a little off because I'm not exactly sure how the case is going to completely close. So I put that over there, and I'm going to push this over and make a decision based on the actual plastic case. So let's push this. Simply put in a note for myself, and we should be able to pull this information in SOLIDWORKS. We can view the changes, and as the changes are coming in, you can simply click on them and you will notice that it sort of highlights the region on this particular board within SOLIDWORKS. So it is bidirectional. You can see the changes that are occurring in both softwares, and you can make decisions just to ensure that there is quality that's in your design process. So I'm going to bring all of this in and accept the changes. So while that those components get placed, we also have the next stage of the design. We've spoken a little bit about collaboration, but we're going to move forward and then get within the schematic phase. So as you can see, I do have my component placed, but let's take a look and see within the casing how this appears. And you can see that it is way off, and I probably need to center this a little bit more, and I was right the first time. So I can get back to the part level, and I could move this with a triad. So I can then apply any of the other mates as we would in any of our SOLIDWORKS designs, and we can push this information back to PCB by simply saying adding our notes to this particular case. Once that's done, it does update on the other end, and you can view the changes and simply update it or select and see what the change is. All right, so we're going to recap once more. It works with native SOLIDWORKS files. It's fast and easy to use and will reduce design time because of the bidirectional nature of this collaboration. So you can either work individually or you can work in teams, and it definitely keeps track of what's going on as this particular design process is in effect. We'll now talk about the schematic process. So in SOLIDWORKS PCB, we do have access to components, and in the libraries you can go ahead and then pull out parts as per your requirement. So we need to go ahead and place this particular component. Let's complete the operation because I need to place just one more, and we'll go ahead and do the same. Now once I've got those components placed on my schematic, I can also go ahead and complete the wiring. So we have the wire tool, and as you can see, it's fairly intuitive, the platform, and it picks off the Altium design tool that was originally the core program. So I can then go ahead and start making connections. So once I've got that one in there, we'll just simply complete these operations and make all our wire connections. You can also go ahead and add net labels to any of the wires, so you can simply place that in there. and then you can define what kind of what type of net label or net property you would like to have over there. So we'll just call this signal 1, and that will map out. Now, as we go ahead and build this, I still want to add one more component to this particular project. For that, we can go into our library and pull out the device. So once we place it, you'll see that it snaps in place, and we can also go ahead by using something called as schematic inspector. So if you click on any of these devices, it gives you more information in detail about this particular component. So for our particular example, we need to stretch this out a little bit so we can take a look at it. For our particular example, we need to simply go ahead and grab the first part of information, because I'm going to go and add some more information to this particular component. To do that, I simply can use shortcuts such as Control-C, Control-V, and when you right-click on this particular component, we have an option called as supplier links. Now in supplier links, you can add suppliers, and this information is real-time. So you can go ahead, search them, it'll sort of give you information based on your price. You can also go ahead and get some more information, quantities stocked or whether it's not available and such. So if we scroll down a little bit more, it gives you more options, and you can simply add these to your component, and you can keep track of this information. So supplier links are live and a very useful feature in SOLIDWORKS PCB. So the schematic capture process usually allows you to go ahead, get circuit design in place. Library management is fairly intuitive. Supplier links is really useful because it's real-time and live. There is also an option for design rule check, and at the end of the day, all this information is directly connected to your layout. So I did mention about design rule checks. I want to make sure I touch on it. We have design rules that can be specified as per the requirement of your design. So you can pre-plan it once you know what your specifications for your project are. You can create new rules around clearances, short circuits, unrouted nets, unconnected, solder mask, paste. So in the end, there is a lot of information available, but at the same time, you can go ahead and create new rules to meet your criteria. I'm going to go ahead and run the design rule check. And as soon as I run the design rule check, you'll see that it brings up a report, and it'll sort of give me all the errors and warnings, and that makes my life a little bit more easier. I can go in there, dig piece by piece, and build on those particular issues and make sure my design is up to the quality I require it to be way before prototyping. Alright, so with that, I'm going to go ahead and then start taking a look at the last part of it, where I want to talk about routing. So in here I have already placed some of my information, and most of this information we've gone ahead and placed some of the components. We've started off the routing. I'm going to go ahead and simply turn off all the layers, so I have a single layer by using shortcuts like Shift S. And for this particular instance, I can always right-click on it and simply say interactive differential pair routing. Now, there are different types of routing. There's just simple one-to-one interactive routing, there's multi-routing, and then there's differential pair routing. So this particular signal over here works around the differential pairs. So we will go ahead and complete that operation. And we can go a little bit closer, and we can start, We can then go ahead and pick these components or these pins on the component, and I'm holding the shift key over here to kind of group select it, and at this point they can simply right click on it and say interactive multi-routing. With that, a few of them will go in there, and you also have shortcuts to go ahead and begin. You can increase the thickness or the width of those particular routes. Now, the PCB layout simply works in a traditional fashion where you can place your components, you can do interconnect routes. We have dedicated design rule checks to help you with all aspects of layout and manufacturing, and routing is fairly intelligent. You can do an auto route across the whole thing, but most of us know that as soon as you get into that, there's always something you want to make look a little bit better in terms of to give you the best type of designs. So coming back to PCB, I have the last part of it where we're going to start talking about our deliverables. Now, in our deliverables, we're going to start working on some of our reports. So if we look at the outputs over here, we have various types of outputs available. We have pick and place, assembly drawings, print, Gerber files, ODB++, NC drills, printing, IPC. You have a design rule check which you can run again, and simply at the end you can bring out step parasolids and such. I personally like to just go down using the generate outputs tool so that you can go ahead and start configuring some of this information. And as the project's being built, the bill of materials is being added in the background. Same thing with these prints, PCB prints. I don't have to do any extra work, whether it's Gerber files, NC drill files. It's just going to configure the style of output. I don't have to worry about how some of this information is going to present. So in here, if I wanted to go ahead and also add a category called checked by, it would add that category right instantaneously. So I do have a vast list of fields available in this. If I don't like where this is placed, I can always bring it over a little bit more and just ensure that it's placed as I would like it presented. You have different file formats that it can be exported to, PDF or XML, web page, CSV, and most of this will follow any of the templates that you have suggested. So in this case, I have a template for Excel, and I can simply click on OK, and once I do that, the application will ensure that all of these are pushed out to their respective destination folders, and we will get the right information for us. So while that's doing that in the back, we'll quickly recap the deliverables. So bill of materials, manufacturing documentation, assembly documentation, be it pick and place or Gerber files and such. Overall, it gives you quality from start to finish throughout your design review, and ensures you have just a checklist to make sure your work comes to closure. So with that, it is a complete solution. We are able to work in a native SOLIDWORKS environment. The information is bidirectional between the two applications. We can work in a schematic capture environment where we have all the information from a schematic perspective. You can manage our libraries really well. Design rule checks exist both on schematic and PCB end. We're able to ensure that there is quality way before we get to the prototyping stage. And all in all, there's intelligent routing, component placement warnings, lots of shortcuts you can use or create to help you. At the end, it ensures you have quality deliverables between bill of materials, manufacturing, and other documentation. So that sort of wraps us up. Overall, SOLIDWORKS PCB solution brings everything under one roof, and really solves quite a lot of an industry requirement to make sure all this information works seamlessly in one environment. And the great thing is it gives you options from schematic capture, traditional PCB. You can also go ahead and use marketing You can use some of this information for marketing by using 3D visualization, seamless mechanical collaboration. You can take it a step further, tie it in with electrical, all under one ecosystem. So let's talk about your design review, manufacturing process, what you think we can help you with. Um, we can help also with providing real measurable and actionable plans. What are you using today? We can discuss the ROIs on these things. We can talk about implementation and training plans. Overall, please feel free to reach out to us. We should be able to help you along your design requirements and your processes.